Alright, hi guys, it's Mr. C coming at you with some level 6 math today. We're doing lesson 2, and there is a lot in this lesson. So this is going to be one of the longer videos. A lot of new vocabulary, a lot of review from last year. We're going to be looking today at multiplying whole numbers and money, dividing whole numbers and money, and looking at different fact families. So let's start with some vocabulary. In division, we have some tricky vocab. For whatever reason, it's hard to remember, even for adults. I even use my notes, and this is in the book, so if you need to review, you can look in the book. But when we have a division problem, we start with a divisor. Now, a divisor is the number you divide by. So if it's 12 divided by 3, divide by 3, that's the divisor. So 12 divided by 3 is 4, 3 is the divisor. In that same problem, the amount that you want to divide up is the dividend. So in 12 divided by 3, 12 is the number you want to divide up, so that's the dividend. And then, of course, the result is the quotient. So after you've divided two numbers, you have the quotient. So in 12 divided by 3, 4 is the quotient. Now that's in division. In multiplication, we're going to deal with two factors which result in a product. So you multiply one factor by another factor, and the end result is a product. Okay, so here we have, this is actually a perimeter problem, and you can solve it using addition. So if you're looking for the square garden and how many fencing you need, that's the perimeter, 15 plus 15 plus 15 plus 15. But we see that 15 is the same number, so we can just multiply 15 by 4. Then that becomes, instead of two atoms to put together to create a sum, now we're looking at multiplication where we have two factors to create a product. So 4 is one factor, 15 is another factor. You multiply those together and you get the product of 60. All right, so this, just to review, numbers multiplied together are called factors, and the answer is called a product. Now in multiplication, we can write this out in several different ways. You'll see you can use a dot, write the factor side by side without a sign, so you can do a number times another number with the normal times. That's how we normally do it. You can also do a dot. It's raised up, so it's not a decimal, it's up higher, and we know that's multiplication as well. Or if two numbers are right next to each other. Now typically we don't do that with numbers. You'll see on the next slide we use parentheses for that. But if you're doing a number times a letter, so if you have an unknown number, we represent that with a letter, then you could do like 6W or something like that. And then you know it's 6 multiplied by W. So that's the way we'll represent that. As I mentioned, we can use parentheses with numbers. So if we're multiplying 3 times 5, you can do 3x5. That's the traditional way to do that. But often in the real world, or using a spreadsheet or something on the computer, we'll use either that little decimal to multiply it by, or even sometimes an asterisk on the computer, or you'll put it in parentheses. So you can do 3 times 5 simply by putting one of those numbers in parentheses, so you know it's not the same number, so it's not 35. And you can do it with both of the numbers, or you can do it the other number. So as long as they're separated with parentheses, then we know it's multiplying. Okay, so now let's review multiplying a 2-digit number. For some of you, this is a piece of cake. For others, this needs some review. So we're going to work through it. When we have multiple digit numbers, those factors, we're going to put them together by basically doing two partial products. Now the first one is going to be multiplying 28 by 4, because we have 28 by 4. And then if we take that 4 out, we're looking at 10. So you can put a 0 just in place of that. So we're really looking at 28 times 4 and then 28 times 10. Now when we multiply 28 by 4, we can do 4 times 8 is 32. So we put the 2 here, carry the 3. Should carry that. Okay. Then we do 4 times 2 is 8, plus 3 is 11. So we get our partial product of 112. Now, if we're multiplying by 10, we're going to drop that 0, and then just do 1 times 8, which is 8, 1 times 2, which is 2, and that gives us our second partial product. Now we can add those two products together. 2 plus 0 is 2, 1 plus 8 is 9, and 1 plus 2 is 3. So we have a final product of 392. you might need to practice some of these problems, and we have some in the practice set for this assignment, and then of course in the regular problems. If we're multiplying by cents, then you can have a decimal here, and the rule with decimals is always count them, how many decimals you have in your problem, and then you'll add that same number of decimals to the end. So here we have a decimal point with 1, 2 digits. So when we multiply these out and get 810, we're going to start at the beginning and go over 1, 2 digits, and that's where we place our decimal. If we had done 6.00 and shifted that over, we'd have to do a bunch of partial products like we did up here with the zeros. And on the next problem, we're going to show you how you can have those zeros hang out. Okay? So, first we need to solve a problem. Let's do this one first, then we'll do the hangout. So 2 dozen pencils at 35 cents each. I'm going to work this with you, and then we'll see how they did it on the PowerPoint. So we're going to do 2 dozen first. That's going to be 12. And then typically you want to put the bigger number on top. That's how I do it. You can do it either way. You're still going to get the same result because multiplication uses the commutative law, which means it doesn't matter which order. So if we're multiplying, 1 dozen is 12, 2 dozen is 24. Let's fix that. So we have 24, and then the bigger number here is 35. Now remember, it's cents, so I'm going to go ahead and put a decimal here so I remember to put that at the end. 4 times 5 for my first partial product is going to be 20, carry the 2. 4 times 3 is 12 plus 2 is 14. All right, now we're going to multiply it by 20, so 35 multiplied by 4 is the first partial product. The second partial product is 35 times 20. So I'm going to drop that 0 for 20. Go 2 times 5 is 10. And I'm carrying the 1 here. 2 times 3 is 6 plus 1 is 7. And that's my second partial product. Now I just add them. Put my $sign on. Look at how many decimals I have. 1, 2. So I'm going to come over here. 1, 2. And have a final product of $8.40. Now, let's see if I did it right. So they did it the same way, put 35 on top, got a partial product of 140, then 700 and 840 cents. So, if it's 840 cents, we're going to move that decimal over twice. 840, got it right, yes. All right, so as I just mentioned, this uses the commutative law, commutative property, which means you can go in any order. 4 times 2 is the same as 2 times 4. You're going to get the same thing. This also works in addition. It doesn't work in subtraction and division. So 23 times 14 is going to equal 322, but 14 times 23 is also going to equal 322. It doesn't matter the order, and we're not going to spend any more time on that. So here, I told you we were going to work with the hanging out zeros. If you have multiple zeros, you can move them off to the side. It's basically moving the decimal point. And you can do that, and then you just have to move the decimal point back when you're done. So the way you can do that is just get rid of those 2 zeros, and then the bigger number is going to be 874. So I'm going to switch that over and do 874 times 4. Now remember, we're just switching those zeros over, so they're just going to hang out here on the end. Okay? Now I can solve it. It's a pretty easy math problem at this point. 4 times 4 is 16. 7 times 4 is 28 plus 1 is 29. And then 8 times 4 is 32 plus 2 is 34. So now we just have our final product of 3496. But then these zeros come back into it. It's not with a decimal, so we're looking at 349,600. Okay, let's check our work with what they've done. So they've done the same thing, 874, drop the 2 zeros, 349,600. Okay, now when we separate a number into certain or equal parts, we're dividing. Remember, we went through kind of that vocabulary earlier. We can indicate division with this symbol, a division box, or a division bar. And often the division bar isn't straight up. It might look like this, kind of to the side, 24 divided by 2. So we've got a lot of different ways to look at that. As a reminder, the answer in a division problem is the quotient. The number that's divided is the dividend. and the number by which the dividend is divided is the divisor. Okay, so this is a way you can draw that out. There's going to be a problem on your homework where you have to write this out. So this is in the book if you need to reference it. All right, so now we're going to divide 3456 by 7. The way I remember which one goes in the box, instead of remembering divisor, dividend, and quotient, I just remember always, when you have it set up in the traditional way, the first number is in the box. Repeat that with me. The first number is in the box. All right, so in this case, 3456 is the first number. That's the one that goes in the box, which means 7 is going to be out here. So now we just go 7 into 35. We know 7 times 5 is 35, and that's too high. That would be too big a number. So we go the next number down, 7 times 4. 7 times 4 is 28. Now notice where I lined this up. I put the 4 in this column, not in this column, because the result is going to be 28, which is a 2-digit number. You want it as far right for that number so it lines up right. So now we can subtract 14 minus 8 is 6. That will cancel that out, and then you get a 0. So 28 plus 6 is 34. We know that checks out. 7 can't go into 6, so we drop the next number down, 5. And 9 times 7 is 63, right? So that's going to be just less than 65. So we'll do 63. Get our 2. 7 can't go into 2, so we drop the next number, which is 6. 7 goes into 26 3 times, which gets us 21, with a remainder of 5, because there's no more numbers to drop down. So then we're going to say remainder of 5. Later on, we'll teach you how to do that as a decimal or as a fraction. It would really be 5/7 is the fraction. And then we could drop a 0 down to solve for the decimal. But today we're just going to say remainder 5. In the real world, we don't use remainders. We do it as a decimal. But that's okay. We're learning Saxon Math right now. This is how we're going to do it. All right. So let's check our work here. 493, remainder 5. It looks like they've done it the same way. Woohoo! 2 for 2. All right. Now, they also teach a way of doing short division where you can simply solve by putting the number up here and then doing mental math. We're just going to work with long division for now, so don't worry about the short division, okay? All right, to check our work, we can simply take what we had before, 493 remainder 5, multiply that by 7. So we multiplied the whole number first, the 493, and then we just add 5 to that. So 493 times 7 is 3451, plus 5 is 3456, which was our original number, so it checks out. All right, now when we do this with dollars and cents, remember, we include cents in the answer. So in this problem, we've got $3.60. We have that decimal on there, and we want to keep it lined up. So we divide that by 4, and we get 90. Then we just put that decimal straight up to get 90 cents. Multiplication and division are inverse operations. So if you take the opposite, 3 times 6 equals 30, you can also do 30 divided by 6 equals 5, or 30 divided by 5 equals 6, okay? So now we want to rearrange these numbers to set another multiplication fact and 2 division facts. You're going to do this kind of a problem a lot early on in the semester, just so that you remember these different properties and laws. So here, 5 times 12 is 60. We know in the commutative law, we can do 12 times 5 is 60. Using the inverse operations, we can do 60 divided by 12 is 5. 60 divided by 5 is 12. So that would look like all these things. Okay? All right, and that will get us through lesson 2. I know it's a lot to take in, and I know for some of you this is a piece of cake because it's just a review, but for others, there's a reason why we review. So go ahead and work through your problems. Good luck.